In the last lab, we used percent composition to get a formula. In this lab, we're going to use the moles of each of the parts of the product to figure out the empirical formula. So it's somewhat like the percent composition, but this time we're going to take a element zinc and iodine and turn it into zinc iodide. The last one we took potassium chlorate and decomposed it into potassium chloride and oxygen. So, as you watch the video, the first thing the instructor did was they masked the flask, which comes out to 100.2236 grams. Then they added the zinc to the flask, and the mass was 102.6750 grams. Then they added the iodine to the flask, and it was 103.2178 grams. They then added the methanol, they mixed it up, the two reacted, they got their product. Then what they did was they poured the liquid which contained the zinc iodide into a beaker, which had a mass of 58.5270 grams. And then they did several washes of methanol in the excess zinc to try to get all of the zinc iodide out. They then heated both the beaker and the flask and let them cool, and when they were done, they had the mass of the flask with leftover or excess zinc coming out to 102.5314. Then on the other side, they masked the beaker and the zinc iodide, and that came out to 59.2076. So below, I want you to do all of the calculations that we're going to use to calculate the empirical formula. So the first one I did, we wanted the zinc before the reaction. So you take the mass of the flask in zinc, which is number 2, and you subtract out the mass of the flask, and you get 1.4515 grams of zinc. The second one, we want the mass of the iodine before. So you take the mass of the flask, the zinc, and the iodine, and take out the mass of the flask in zinc, which leaves you with 0.5428 grams of iodine. Then, to calculate the mass of zinc after the reaction, assuming all the iodine was used, we use number 5, the mass of the flask and the excess zinc, and we subtract out the flask, which gives me 0.3078 grams in excess. Now, to calculate the mass of the reacted zinc, what we're going to do is we're going to take the mass of the flask in zinc, subtract out the mass of the flask in the excess zinc, and that gives you 0.1436 grams of zinc used. Now I need the mass of the product, so I do mass of the beaker and the product, subtract out the beaker, comes out to 0.6806 grams of product. And to calculate the mass of iodide, you kind of have to look at the second chart and take letter E, which is the mass of the zinc iodide product, and subtract letter D, which is the mass of the zinc used, and that means you have 0.5370 grams of iodide, because 0.1436 is the other part, that is the zinc. So now I'm going to place all my stuff into my table. These are my answers from the previous ones. Now, to calculate the moles of zinc, what I'm going to do is I'm going to take the mass of zinc, which is letter D, and I'm going to then multiply by 1 molar over the molar mass, which comes out to 0.02196 moles. Then to do the mass, or the moles of iodide, I take the mass of iodide times 1 mole over its molar mass, and it comes out to 0.004232. So now for number 3, I want to convert them into an empirical formula. So what I do is I take the moles of each. There's my moles of zinc over itself, and there's my moles of iodide over zincs, because it's always the lower number. When I do that, I get 1 mole of zinc, 2 moles of iodine. So here I did it again, so you can see it. What is my final formula? Well, ZnI2, because remember, the subscript is the moles. So does this match what we did in Chapter 9? Well, of course it does. In Chapter 9, we said we take zinc, and then we take the iodide, and we crisscross them. and we get ZnI2.